Welcome back. Our overall topic is around a trilateral symposium on agri-food innovation focused on climate-smart agriculture and food security. The first session was really about setting the framework of what's going on in agriculture in these three different countries. What we will now be doing is moving into why, with all the success we've had in taking care of feeding the world that we did over the last 30, 40 years, why that system is not going to work for the next challenge that we have to take on as a society. So we're going to spend a few minutes observing and understanding what is the challenge that we are facing. And then we are going to have a tremendous panelist here from Israel and here in St. Louis, working and talking about how we're going to build this 21st century climate-smart agriculture. My name is Vijay Chauhan. I lead the Global STL initiative at BioSTL. And what Global STL does is it figures out how to find the best innovations from around the world that is coming to the United States, but doesn't necessarily think about the Midwest. They all think they have to go to Boston and Silicon Valley. And it's surprising even ag and food companies think they need to go to Boston, Silicon Valley, when the market and the customers are here. So our goal at Global STL is build a magnet to get them to come to our region. And those companies that we are bringing here are here to bring value and competitive advantage to our farmers and our corporations in agriculture and food. So we are a global connector. I have with me on this panel Mike Graham, who heads up all of breeding for the Bayer Corporation. As you all may know, it's the largest agribusiness corporation in the world. We also have Anya Eldan. She will be showing up a few more times in our panel discussions today. She flew all the way from Israel to be part of this symposium. And Anya has done a tremendous amount of work in building innovation ecosystems in multiple domains, but we'll be able to talk about what we are doing here in agriculture and food. And then I have Ram Fishman. Dr. Ram Fishman is faculty member at Tel Aviv University. And he actually works with smallholder farmers around the world. And it's in the area of climate-smart agriculture. Is there a way for you all to cut the delay that's taking place in the recording?
We like hearing it twice.
There you go, Anya. Maybe the second time the message gets through. Yes. So what I want to do is just start with, so Ram, welcome to our panel. And I know you are in Tel Aviv right now, and I love your backdrop. So are you able to hear us, Ram? OK, can you make sure that Ram's able to hear us? Are you able to hear us? OK. Work on that problem, too. OK. So we're going to talk about building 21st century smart agriculture. So one of the things that's really been impressive is in the last 30, 40 years, we as a global community have doubled our population. And the doubling of population, we were able to successfully keep the world fed by and large. And the reason we were able to do that is with something called the productivity miracle. So if you take a bushel of corn and you look at what it took to produce that bushel of corn between when we started this journey 40 years ago versus today, it takes 40% less land. It takes 60% less erosion, so doing a good job of keeping the soil in good condition. We are requiring 50% less water and 40% less energy, and 35% less greenhouse gases. So if you are talking about building a climate-smart, sustainable agricultural system over the last 30 years, we've done it. And we could all rest on our laurels and say, job done, keep doing what we are doing. And unfortunately, we're going to talk about here in a few minutes, that would have been great if our population was going to be stable and the diets were not changing around the world. But those are not constant. We are headed to a doubling, a growth of our population from 7 to 10 billion people, and the diets are changing around the world. So the good news is, had we not done this, we would have needed 5.5 times more land than we are using right now to accomplish this increase in food production. So we were able to save a whole bunch of land as a result of it. And why that's a big deal is if you think about agriculture today, this is the footprint of agriculture in the world. We are using 40% of all the land that exists on the planet today. So if I were to just multiply that by 5.5, you can see the whole map being consumed. So there was no way in which we could have used the methods that we had 30, 40 years ago. And so we are already using a lot of land. There's not a lot of land to go. We are using 70% of the water. So we don't have that much more water left to use, because after the 70% that's used for agriculture, everything else, for drinking water for cooking, water for the industry, that's what the 30% represents. And then if you think about what this water represents, I've got a really interesting visual. Watch how the Aral Sea from 1973 to today has transformed. This is about how small it is today. The quality of the water is not good. No longer is this resource one that agriculture can count on. And then we are emitting 25% of all the greenhouse gases. So as successful as we were in reducing it, we still are a huge impact. So with all of that in place, the question is, can agriculture save the planet and feed its inhabitants? It's always been on feeding the inhabitants mission, and now we are asking it to take on the next mission, which is also to save the planet, not by itself, but in partnership with all the other changes we are talking about. And to pull this off, studies that have been done have said this is what needs to be done. And that is, the story is more than just increasing the yield. It's how we go about doing it that really matters. So increasing food production by 70%, turning agriculture from a net carbon source to a sink. You're going to hear today some fantastic innovators that are doing this. If you come and stay for the innovation panel from 3 to 4:30, you're going to hear a couple of folks who are doing some great work in that area. Nitrogen, reducing the atmospheric nitrogen that's converted to fertilizer. We really want to figure out how to change how nitrogen is being used. Water, we need to figure out how to keep fresh water use below the 4,000 kilometers per year level. We are at 2,600 right now. So we just have a very short amount of gap to use the rest of it. And then using cropland to keep it under the 12 to 15% of Earth's surface. These are the goals that have been set for us to be able to feed the world and yet reduce the carbon footprint, becoming a carbon sink. All right, so with that as the background, I'm going to start with Mike Graham here, who spends every day and every waking moment, not only of his, but his entire team around the world. And so Mike, it would be lovely if you can tell us a little bit about Bayer Corporation.
Yep.
For folks who may not fully understand the scale of operations, the kind of businesses you are doing, particularly on the agribusiness side.
Yep, wonderful. And it's great to be here today. It's always a pleasure to get the opportunity to talk to individuals, teams, people around the world that actually have an interest and a passion for what we do in agriculture and the impact it can have on our customers and the planet. So I'll start with one of my favorite pictures, and this gives you a little bit of idea of what Bayer does and what we've done in the past. This is actually a picture that was taken about 2 years ago. And it was a picture that was taken just north of here up in Jerseyville, Illinois, which simply laid out for people that we brought to this farm what it would take and how technology has impacted the amount of land that's needed to produce 10 bushels of corn. So if you look at the far right on this slide, or your left, I guess, It would take in the past that in 1940, that was the amount of corn you would need to get 10 bushel acres. So you can see a massive strip of land that was needed to just get 10 bushels of land. And you could start thinking about the evolution that's happened from 1940 to where we are today and the implications that has had for food production. So obviously the big one simply back in the early 40s was the development of hybrids, which allowed a grower to get a lot more yield off their acres, off their land, and this technology was available and used around the world. This then led to the application of new technologies. So advancements in breeding, advancements in biotech, advancements in crop protection, all of which are areas that Bayer has focused on for many, many decades in advancing those innovations, led to the ability to continue to reduce the amount of land that was required to deliver the same amount of yield. And as you look through this, you can get to the end of this graph, and this is a picture of our short corn, which we now believe will be the next big change in what will happen in agriculture, which will simply be delivering more yield, but doing it in a way that is good for the planet and good for our customer. Now, we love data, and you'll see in one of the slides that are coming up, and I was happy to see, Vijay, that my numbers actually look very close to the numbers that you shared. We actually ran a study of the last 3 years looking at commercial hybrids that had been deployed in the 50s, 60s, 70s, 80s, 90s, 2000, and 2010, and putting them in massive trials around the Midwest to understand what has changed. And the metrics you see there are very much aligned with what you shared, right? Which is the hybrids that were released in the 20s, the more recent hybrids obviously had the ability to yield more, so you reduce the amount of land that you needed. If you think about the amount of nitrogen that is needed to deliver more yield, that's continuing to grow. The same on the water, and this was the example that you had on the amount of water these products need. And then on the ability to capture more carbon than what our earlier hybrids had. These were all capabilities that we've been able to demonstrate with the new capacities and new technologies. And so these are innovations that companies like Bayer have brought to the market to enable us to solve the problems that we have today. But as you highlighted very well, we've got massive challenges in front of us. And if you think about that graph that I just showed you, that picture of how the amount of land could go down, if we don't change the way we're thinking about how we develop and generate that next generation of product, that graph actually, or those pictures, have the opportunity to increase, meaning that we will need more land than what we do today to simply do the same thing in terms of the yield that we can generate. And this team knows very well the increase and the impact of demand. You covered it very well. And also on the flip side, the impact on supply and what the implications are going to be. So as a company, and particularly within R&D, within Bayer, we've spent a lot of time thinking about how do we solve these problems. Not only how do we bring a solution to our customers today, but how do we build the necessary information, insight, knowledge, and get it all connected so that through that we can start developing that next generation of product that is designed for a customer and also designed for a future environment. This always starts with data. So 10 years, I would have given this presentation, I would have told you it always starts with germplasm. Our focus today is data. And what we are building around the world is an ecosystem of sensors, images, soil understanding of soil environments, all of which allows us to connect every seed that we plant to the environment in which it is, to the outcome that it generates, so that we've got this massive amount of data that informs how we design that next generation of product. Obviously, that informs and that data allows you to think differently about the application of data science. And this has been a core investment and capability for our organization as we started to think about how do you take that data and do something very different with it than what we would have done in the past. We then allows us to get some really interesting outcomes. So these are just a few of examples of things that we're currently working on within Bayer, within the R&D organization, but this slide could have gone on for many sections. But we have a concept that we call precision breeding in my organization, which is simply the ability and the desire to be able to design that next generation of products but doing it in a way that's much quicker. So if you think about 1940 to 2020 and those 80 years, we want to compress that period into 20 years. And that is a capability that we're building through the investments that we're putting in place for precision breeding. Lots of discussion today on genome editing, huge potential, huge opportunity, but many challenges to think about. What do you edit? How do you bring it together? How do you make a product out of it? How do you ensure that you've got the approvals in the areas that you want to release it in? And so this is a technology that we're spending a lot of time with, both thinking about the technology itself, but also how do you create a product out of it? And this takes time and energy, but a key area of focus for our organization. Lots of recent examples from Bayer on biologics. You've seen, or some of you have seen maybe the announcement with Ginkgo Bio. A huge opportunity, not only in terms of the collaboration, but really thinking about what both of those, what Bayer and they bring to that collaboration to really enhance the way we think about the opportunities to use biologics in our products. And then last but not least, we're interested in creating new systems. So when we think about what a corn crop could look like, what a wheat crop could look like, what hybrid rice could look like in the future, they don't look the same as they do today. And this is maybe the biggest challenges for all of us, in that these systems need to change for us to continue to develop the yield that we need to deliver, but also to do it in a sustainable way. And lots of incredible examples of how that's turning into actuality with short corn, how that's turning into actuality with hybrid wheat, and our investment and interest in direct seeded rice, and the application that could have in many parts of the world as we bring that online.
Great. Thank you, Mike. We'll come back and talk about a few of these in a little bit more detail. Want to just get to Anya for a second, and then Ram will be coming to you. So Anya, you have been working at the Innovation IIA, Israel Innovation Authority, for the last 7-8 years, and really unleashing the entrepreneurial and innovation capacity of Israel to solve for big problems. As it comes to 21st century climate smart agriculture, can you just touch upon a couple of examples of initiatives that when you were there, you said, we got to do something in this area, how you came to that decision, and what did you all do there?
Thank you. Well, you have me talking later on about the Israel Innovation Authority, and I will also talk a little bit about an example on how to build an innovation ecosystem, and I will use the alternative proteins. So I will give some other examples now. But I just want to say in terms of alternative proteins, you know, I mean, it's not, this is not a place to discuss it, but, you know, I realize I'm in the livestock country. But the climate impact of growing meat is huge. And the demand is growing. So I don't think anywhere in the near future or in the next 50 years, you all will stop eating meat or the growers will stop growing livestock. I just think that the added demand that we have from additional growth could be replaced by alternative proteins. And it doesn't mean that we want to tell somebody don't eat meat. We just want to create meat in a more sustainable way. And the whole ecosystem of alternative proteins is exactly that. How can we create delicious and sustainable meat without actually growing livestock? And I was a little shocked by the numbers of agricultural land that you put, somehow 70%, or it didn't sound like it should be so big. But you know, in some countries, 80% of that growth is to feed livestock. And if you think of thermodynamics of food, it takes almost 40 calories to create 1 calorie of beef. So this is not a very efficient system on creating food. So we think that the technology can change and the innovation can change how we create food in many different ways. As I said, I will address alternative proteins later. But I brought you some examples, and Michal talked before, and she mentioned the agrivoltaic pilot that the government published, which I thought was pretty innovative and amazing. And And it's amazing how innovative energy companies actually investing in agriculture. And there is a very innovative company called Doral. And if you look on LinkedIn, they have a lot of literature about it, how this connection of alternative energy and alternative agriculture can actually make big changes. So I was very impressed by Israeli government putting that tender. I think a lot is going on about molecular farming. So the idea that you can grow proteins that can be expressed by plants, it's not new. But we're looking today at the areas, for example, in alternative protein, a company like BioBetter is expressing growth factors in a very scalable and cost-effective way in growing tobacco. And it's a crop that can grow anywhere. They have locations in Israel in very cold and very hot. So molecular farming is a big trend. I think it's going to change a lot of how we do things together with the fermentation technologies. Indoor farming, I'm very much excited about vertical farming and indoor farming. We haven't had so much innovation in Israel in that area, apart from areas growing lettuce on roofs. And it's nice and warm there. But one company I wanted to mention, they're called Green Onyx. They actually create a robotic sort of modular growth units. And Green Onyx uses duckweed, which is the smallest, very nutritious green vegetable, full vegetable, very tiny. And they have those units that can be put in urban environments, and they automatically produce this fresh, green, quite tasty stuff. I don't even know if it's a vegetable.
Yeah.
So it took the Israeli regulator 2 years, and they finally declared it to be a vegetable. So it solves a lot of, it's not funny, it solves a lot of regulatory problems. So again, this is my favorite example of indoor farming. I think with the change of climate and the crazy weather we've been having, this could be very interesting. Another field, again, Michal mentioned, all the algae and microalgae and different bacteria. So I'm very excited about a company called Simply Good that generates spirulina, fresh spirulina. It's not the smelly thingy that you buy in capsules and it's really disgusting, no. It's fresh. It's completely neutral taste. And they have a very smart, high-yield agriculture way of growing it. But the exciting piece for me is that they were able to take the green out of spirulina. Spirulina is this thing that you add to your shakes and they turn green. So they managed to take the green out and still have over 60% of protein in the biomass that they generate. So now they have a collaboration with DuPont and with other companies for creating smoked salmon and alternative smoked salmon, and another fish product from that. And that's a completely agriculture product, but when it comes out of the agriculture, it goes into the reactors, and you create this alternative protein biomass from it, with yields many times more than just irregular agriculture. Another thing that is very strong in Israel, and I personally was kind of not so excited about robotics in agriculture. And the first, at Innovation Authority, we see thousands of projects. They come to us for money, so lots of robotics all of a sudden came. And everything that moves and does something is a robot all of a sudden. So robotics that do things in the field. One of the exciting companies is Tevela Robotics. They actually pick up apples with those drones. So these are nice drones. They are sort of connected to the ground, so they can work for hours and hours and hours. And with the workforce not being available, so much anymore in this business. I don't know how it is here, but in Israel, nobody wants to work in agriculture. So we bring workers from Thailand, and there is a very limited number that agriculture can bring. So huge problem with workforce. So those companies, another robotics company called BeeWise, and you know what happened to bees in this, on this planet? So BeeWise is a AI-based robot that helps grow bees and sort of return the bees communities back to the farming. Very, very interesting company. I personally don't need the products, but another company that's really great called BioDvash. Dvash is honey in Hebrew. So they actually make honey in fermentation, using fermentation technology, but the honey has the same bacterial structure as the regular honey that bees make. So you can actually drink it with your tea when you're so cold, like it's here.
So Anya,
And
yeah.
just one more.
Yeah.
I have this, I have to say this. So I really like I don't know if you're familiar, but this whole area of generative agriculture.
Yeah.
It's hard to say. And yesterday I just remembered that in Jewish religion, religious people don't eat any crops that are grown in the 8th year. Correct me if I'm wrong. 7th year. So every 7th year, you don't grow anything, you let the land rest. So somebody way back was already implementing this term. And of course, during that 7th year, which finally ended last month, you can't really get the stuff you want from your grocer if he happens to be religious. But I think this cover crops, all the technologies that can help the land work better are also very interesting. And I know Bayer is doing stuff in that area. This is very important. That's it. Sorry.
Well,
I
Anya,
talked too long.
well, you threw some wonderful examples there. We'll come back and talk a little bit about all of that. We'll bring in the audience into this. But I want to pull in Ram Fishman. Ram, you actually are working in a very different part of the world and a different set of farmers and communities. And given that this is a problem that is not just of the Western economies, if we're going to be building a 21st century climate friendly agriculture and food system, it's got to be one that works for all the citizens of our world. So Ram, why don't you introduce yourself a little bit and talk about the work that you're doing at your Nitsan lab and your work around the world.
Sure, thank you, Vijay. It's really nice to be here. I wish I could join you in person, maybe next time. Yeah, so as you say, Vijay, I think you set this up very, very nicely. The global food challenge cannot be solved without the involvement of the hundreds of millions of small-scale farmers who dominate agriculture in low and middle-income countries, whether be they in China, in India, in other parts of Asia, in Africa, in Latin America. That's clear. We know the calculations show that we could solve a big chunk of the shortage of food that we discussed if only we could get these farmers, these small-scale farmers, to close the yield gap and achieve the same productivity that farmers in Israel and in the US are able to achieve, or even close to that. And there, the challenge is not a technological challenge so much as it is a challenge of making these technologies work for these farmers. The issue is that these farmers are not very productive, and they also make excessive use of environmental input. Some people think small farmers have a romantic idea of small farmers being very ecological or environmental. In fact, small farmers use pesticides, water, and energy less efficiently than farmers in high-income countries, large-scale farmers. So the challenge is to transform smallholder agriculture in low and middle-income countries And the thinking about these farmers has really changed in recent years. Um, they used to be something that philanthropists would think about, right? It would be a charity case. But now more and more we are realizing that these are emerging economies, emerging markets with huge potential for business. I personally think that the private sector has an enormous role to play in transforming smallholder agriculture in these countries. That would be good for business. It would be wonderful for global challenges, food challenges, environmental challenges. But we have to make a more concentrated effort to bridge the gap between the world of modern farming in high income countries like the US or Israel and the day to day realities of these farmers. I'm an economist I've been studying these farmers for more than 15 years now, and I can tell you two things. They are not bad farmers, they are not lazy farmers. They deal with stress and challenges that dwarf some of the challenges that farmers in Israel and the US have to deal with on a day to day basis. They are good farmers, but they are constrained. Their circumstances are different. So we have to make an effort to adapt the technologies that we use or produce new innovations to their needs. And this has tremendous potential for transformation. I can also tell you from my experience with these farmers that whenever I go in the most remote villages, whether in India or in Africa, somehow these farmers have this amazing appreciation and admiration for Israeli agriculture. I don't even know if they even heard about it. But as an Israeli, it's a very heartwarming thing, but it also makes me aware, acutely aware, of the responsibility we have. Many farmers in those worlds are looking towards Israel as a source of innovation and solutions to their challenges. Now, our leaders have understood this in the early days of Israel, starting from Ben Gurion and going on to Golda Meir. This was part of our national mission, but it has been sidelined over the years. And I think it needs to be revived. And our leaders are beginning to realize more and more that this is an important geopolitical strategy for Israel. It's important for the world. And people are talking about it more, but we are not still doing enough. And I actually believe that the partnership between Israel, the US, and the UAE provides us with a golden opportunity to really revive those efforts and to bring them to fruition. Israel and the UAE both have strong agricultural sectors, obviously the US, but Israel and the UAE located right there in the middle of this world, towards South Asia and beyond, climatic, to our west, Sub-Saharan Africa. Again, they're admired to Israel because they know this is a country that has managed the same kind of climate, dealing with this, and also naturally see it as a source for where they can inspiration and solutions. But we need to take this on in a bigger way, and I think the partnership here, when we talk about the need for finance, the need for bold innovation, the need for policy in those countries that will be aligned with that mission is tremendous. It has to happen at the policy level, but it also has to happen at the private sector level with businesses attacking it. And I think that with Mike and Anya here, it's an opportunity to talk about a partnership that we started with Bayer and the Israeli Innovation Authority, actually, and with the support of the Fuchsman Foundation, where we are actually trying to take this on. So my lab at the university, I was educated in the US. I spent 10 years in US academia, and I moved back to Israel because I wanted to develop exactly this mission. We have to, so what my lab does is to work with Israeli innovators, private sector companies, and to bring them into this world, to help them bridge the gap. Our students spend months and months in the field, in villages in India and Africa, to bring Israeli innovation, install them, test them, adapt them, understand the barriers that prevent smallholders from using them successfully, and try to overcome them. And this new partnership between ourselves and Bayer and the Israeli Innovation Authority will now scale this up. And we hope to be able to bring in many more technologies to this space. The biggest success story here is drip irrigation. Of course, the famous Israeli innovation, actually something that you see more and more in more places in India, helping India deal with its water crisis, severe water crisis. We want to accelerate the introduction, development, and diffusion of the next drip irrigation, of the next 10 technologies like drip irrigation that can come out of Israel or the UAE or the US and transform smallholder agriculture in those places, which is a key for leading us all to a more sustainable food future.
Well, Ram, that was fantastic. You know, it changed my understanding of the problem. Here we are thinking we just got to take our existing farmers to another level. And you just said there's a whole nother group of farmers who just need to get to the level that we're already at. And so that's a very different type of problem to solve for. But it's actually hopeful where it's not their technology, but it's understanding how do you bring value to those farmers. So Mike, I know you'll have been doing a lot of work and thinking about this at Bayer. Anything you want to jump in and share about how the company is thinking about these kinds of farmers, not just our big mega farmers?
Yeah, maybe. And I didn't realize that we had a partnership. So this is it's always good to have a panel so you can know who's working on what. So it's great.
I didn't know Israel Innovation Authority funded that. So.
But obviously, this is an area of keen interest and importance to us. And I think you articulate it really well. If you looked at the kind of the crop graph that I shared of the changes in innovation here in North America, if you look at a smallholder farmer, that is essentially flat. So if you take simple measurements like genetic gain for a smallholder farmer, that number has not changed over the years. It's changed a little, but not anything significant. So all of this technology has not reached the products that they're actually planning on their farm. If you then take it to a different level and you simply look at how often does a farmer refresh their product, if you're a smallholder farmer, it's typically between 14 and 16 years. Now, obviously, that varies. It varies by country, varies by areas. But you compare that to what a farmer would do here in Missouri, for example, which would be every 4 to 5 years. At the latest, they're switching out a product. They're bringing in new genetics, new technology, new innovation. And so what we set out as Bayer is we have a goal and an ambition by the year 2030 to connect and influence 100 million smallholder farmers around the world. We're spending a lot of time actually working through collaborations to develop new capabilities, new ways of experimenting, to actually inform both how those growers and how those customers are using products, not Bayer products, but just products that optimize their solutions and their farming practices, and then helping connect that to digital capabilities. So thinking differently about the value that a grower may have from a cell phone, and they all have cell phones. And so how do we use that as a technology and a tool to not only provide information, provide insights, but also a vehicle that we can conduct businesses in a very different way. So access to finance, access to information, all of these kind of capabilities. So we've been on this journey. A number of you may have heard about the centers that we're starting to build in India that are really centers for us to help a grower understand the solutions that are available, help educate growers so that they can get better insights of how to really manage a crop or solution a different way, and they're having a big impact. But we're not we've got a big target, so we've got a long way to go yet.
But it's great that y'all have got that goal, 100 million of them by
2030.
8 years to go, 7 years to go. Ram, you were nodding your head vigorously when Mike was bringing up some of those points. Could you share a couple of examples of these kinds of innovations, smartphone-based innovations that are really getting smallholder farmers to adopt solutions? Love to hear some examples.
Sure, I was nodding vigorously because I think the digital domain is very promising indeed. You know, one of the problems with agriculture in low and middle income countries is that every extension worker, whether they're government or private sector, has to cover perhaps 1,000 farmers. And it's just impossible to do that effectively. So one of the biggest challenges is to actually reach the farmer with information, with knowledge, with market access, with anything. And here the digital revolution really provides us with an opportunity because, you know, almost all of these farmers already have phones, and many of them now cellular phone, mobile phones. Many of them now have smartphones. And this opens a whole world of possibilities, and people have been working on using it to provide insurance, to provide market access, to connect them to information, to extension, to know what's happening in these farms without having to go there, and therefore be able to provide farmers with very precise information and advice. Um, Detect their pests, deal with their pests, a whole range of possibilities. And some Israeli companies have also been on the forefront of it. We're talking about sensors or a combination of sensors in the field and then remote sensing from satellites that can tell a farmer when they actually need to irrigate their crops. And there's a number of companies in Israel that are working on this front, starting from the big ones, whether it's the Jane or Netafim, Nandan, Rivolis, but also small startups like Supplant and other very interesting companies that are developing technologies that will basically able to tell you, you will be receiving as a farmer a message on your phone that will tell you you need to irrigate right now because there's not enough moisture in your soil or your plant is feeling a stress. And some of those evaluations they've conducted suggest that you can save enormous amounts of water in that way, even after you already have a drip system installed. So the potential for water saving in this way is tremendous. However, it's not that easy because even though the technology may work perfectly well, there's the human factor. And the human factor is both a challenge and an opportunity. It's about getting farmers to trust this information. It's about getting them to act on this information. And this is a complicated behavioral challenge, if you will. Behavioral economics is a way of thinking about how these farmers make decisions that may not always seem fully rational to us. It's about understanding their constraints. I fully believe that these farmers are much more rational than we actually realize. They seem to us to be making bad decisions because we do not understand their constraints well enough. And that's why in our lab and in our program, we try to improve that understanding sufficiently in order to enable the amazing innovators that we have in the US, in Israel, and other countries to actually develop not just the technological side, but also to make it the design for the customer, for the right customer, to make them useful and usable. And then I have no doubt that these farmers will make wonderful use of these solutions. So those, in terms of the digital domain, were the great promise.
Yeah, tremendous head nodding going on here because one of the things that we are all appreciating is if we do not understand from the farmer's perspective what the challenges they are, and we simply provide this solution that we think is so obvious, not making that connection, the human factor connection, the way they see the problem, that disconnect causes a lot of barriers for adoption. And the reason that I want to just spend a minute on this topic is here, right here in the BioSTL organization, inside the Global STL Initiative, we launched a program called EGIC, Early Adopter Grower Innovation Community, to build a new pathway for how a farmer adopts innovation. And it's based on exactly the thing they're talking about. How do we sit down with the farmer as a customer and sit down and understand how they are taking on the challenges of keeping the food on the table, their operation going, and the holistic elements of it. Not just, we have a solution and we just want to understand why you're not adopting it, right? Understanding their perspective. And in Missouri, we are really a state of smallholder farmers. By and large, we are not a big acre farming operation. You heard that from Garrett's previous comments. So anyway, those are the points of connectivity there. Two things one for Ram, and then I'm going to get to Anya here. Ram, you have this amazing program where you understand how to connect with these smallholder farmers. Is it possible for students in St. Louis and United States who might be interested in coming and joining your lab or somehow some kind of a virtual program where we can gain insights on how one actually understands how to serve these farmers, and then bring the innovators alongside.
Thanks for this, Vijay. Absolutely, it would be wonderful. You know, I think at this time and age, there's really no more need for the traditional forms of education, certainly not in higher education. There's no need for students to come and spend some of the most vigorous and exciting years of their lives sitting in a classroom, listening to somebody like me just say something that they can watch online or read online. It just doesn't make any sense. I believe that education at our time has to be about bringing in those students to work with us on global challenges. By working on them and dealing with them and confronting them in the field, they will not only make a major contribution, but they will learn so much more than by just listening to professors like me just blabber on. So this is the approach of what we're trying to do in this lab, and we very much would welcome more collaborations into this program. We would very much welcome taking students with us from universities in the US. And in fact, you know who my closest collaborators are in my academic work, in my research work in India? These are researchers who are based in NYU Abu Dhabi. And that actually happened even before the Abraham Accords. Academia has a way of crossing these boundaries. So now we are planning to actually bring students from NYU Abu Dhabi to work with Israeli students on the ground in India or in Africa. And I think it would be wonderful if we could also include students from the US, from Missouri, or anywhere else where some of these challenges share the same core elements. I think it would be absolutely wonderful if we could do that.
Excellent. So we've got 5 or 6 minutes left. I'd love to invite anybody from the audience who's got a burning question. If you would like to, just come up to the mic here and ask it. And if you don't, that's OK, too. So while people are thinking about that, OK, I think we've got a person ready for a question. Hey.
Good morning, Vijay.
Hey, Mike.
I'd like to say that I'm a professor at UMSL and teach in the College of Business, and not everybody in agriculture is a farmer. But I take students to the UAE, and we visit people like Pure Harvest, courtesy of Bayer. We come to Israel as a startup nation and go see your technology and your industrial complexes. But we need to have more cooperation from industry to help us let more students who are not necessarily directly in agriculture understand the transformation that we need. And taking them to the UAE and Israel is a great way of doing it.
Well, thank you for sharing the fact that we are doing this, and now we can take it to the next level. And there we've got Ram saying he's ready for it, and now we can do it virtually. So the world's changing in front of us. Anybody else has another question? Yes, Phil?
What are the biologics that you're talking about in agriculture?
So Phil's question is, what are the biologicals that you're talking about? Now, you know, if I can think about where Phil's question is, this is an area that has been full of disappointments. A lot of hope, a lot of expectation that we finally have solved it. It's a very complex solution environment. And you know, Bayer is probably one of the few companies that has gone around this a few times. So Mike, can you kind of give us a sense of the tangible, real opportunity here?
Maybe I'll preface my answer with, my dad is a soil microbiologist, and he spent his career looking for microbes that would benefit plants, and his focus was really driving an impact on smallholder farmers. So that was what he was focused on, and that was his passion. And in fact, he was very successful in finding and identifying unique microbes that actually had a beneficial impact. And these were Bradyrhizobia, so this was the main focus, but really using them in a different country in a different way. We've historically had, and we have now again, a broad collaboration looking at different microbes and evaluating for things like disease tolerance, early germination, iron chlorosis, those type of effects. The types that we're looking at is very wide, so there's many different types that we look at. We're also exploring how do you develop them, and so how do you continue to evolve those so that they can actually accelerate the advantage that they bring to a product. So no specific ones. super complex. So there's no easy solution, and this is why we felt that this type of work was better set up for collaboration broadly that leverages the capability, the assets that we have, but the insights that other collaborators have on what we should be going after and what we should work on is coming from them.
Can I add something to this, Vijay?
Yes.
So I was just telling Mike that one of the companies I have put down here is called IBI Ag. And it's actually a company that was started by Bayer in Israel. So I don't know if you know, but Bayer is working in Israel with one of the incubators, with Trendline's incubator. And I had a meeting with two gentlemen who came to my office when I was in the office. And they said, you know, we saw 25 companies and none of them are relevant. So I said, in Israel, you don't scout. In Israel, there is so much, everybody is so entrepreneurial. So you come with your problems and somebody will come with solution. So they did a challenge and they started this company. It's actually biological insect control with a single domain antibody that affects that specific insect, but not destroying the good stuff around it. So there's at least one biological company that Bayer started that's looking good. And I wanted to make one more comment about irrigation. I think in my 7 years in the office, I had supported 20 startups in Israel that are doing something very similar. So they have a certain sensor, and then it could be a satellite image, and they do a certain amount of analysis, and then they provide the farmer with this application that tells him you should irrigate. The problem with all of those is, first of all, each application works for one crop and one type of area, and they all provide information that leads to over-irrigation. So, and even the drip irrigation invented in Israel, a lot of those installations provide for over-irrigation, because when you close the system, it takes another half hour until the water gets out of the system.
So I wanted to close out this conversation by making an observation, which is we can keep talking, right? Look at the conversation we're having. So thank you, Mike. Thank you, Anya. Rams, safe travels there, and we'll see you soon.